BMTC-132 differential equations. Block 1 functions of 2 or 3 variables. Unit 1 r square and r cube. Unit 2 limit and continuity. Unit 3 first order partial derivatives and differentiability. Unit 4 higher order partial derivatives. 5 chain rule and homogeneous functions. Miscellaneous examples and exercises. Block 1 functions of 2 or 3 variables. This is the first block of this course on differential equations. The purpose of this block is to give you a foundation for studying differential equations course by introducing you to functions of more than one variables and extending the concept studied for one variable function in calculus to 2 or 3 variables. You are already familiar with some aspects of the calculus of function of one variable from the calculus course. BMTC 131, Newton and Leibniz are considered to be the founding fathers of calculus. The major development in calculus took place in the 17th century. Later in the 18th century, the basic concept of calculus, for example, limit, continuity, and differentiability, were extended to functions of more than one variable. The need for studying functions of several variables arose when some mathematicians like Euler, Daniel Bernoulli, Fourier, Augustin Louis Cauchy, and D'Alembert were investigating some physical problem. Augustin Louis Cauchy, 1789 to 1857, was a dominant mathematician figure in Paris, the center of the mathematical world in those days. Cauchy too has contributed to the development of several variables to a great extent. The block is divided into 5 units. In Unit 1, we begin with describing the structure of r squared and r cubed. We introduce the notion of a distance between 2 points for r squared and r cubed and deduce its elementary properties. We define functions of 2 or 3 variables defined from r squared tends to r and r cubed tends to r and gives various examples of such functions. These functions are commonly termed as real valued functions of several variables or simply functions of several variables. The concept of level curves and level surfaces are also introduced, which are used to describe respectively the graphs of 2 and 3 variables function. We shall define the concept of limits and continuity for functions of several variables. In Unit 2, we discuss the term simultaneous limits and repeated limits and give the connection between them. In Unit 3, we extend the notion of differentiability from one variable to 2 or 3 variables. We first define the partial derivative of a function of several variables. The notion of partial derivative does not fully generalize the concept of derivative of one variable functions. Later, the concept of differentiability for a function of several variables is defined. We discuss the connection between the differentiability, continuity, and existence of partial derivatives. The concept of first order partial derivatives gives rise to the notion higher order partial derivative, which is covered in Unit 4. We discuss some important theorem known as Young's, Cauchy, and Euler's theorem, which gives some sets of conditions under which that makes partial derivatives become equal. Unit 5, the last unit of this block, covers some applications of partial derivatives. We discuss chain rule to evaluate the partial derivatives of function of 2 or 3 variables, where each variable itself is a function of 2 or 3 variables. Here we also define homogeneous functions and explain Euler's theorem for homogeneous functions. The concepts which you are going to study in this course are bound to be a little more complex than the corresponding concept for functions of one variable, but you will see that one variable case shows us the way in which this concept could be generalized. So each time we introduce a new concept, we will recall its parallel in the one variable case. and then see how it extended to the several variable case. We have interspersed the text with a lot of solved examples. These examples will help you understand the theory better. We have been given the answer of all the exercises in each unit at the end of the unit. As you will see, we often have to refer back to result or definitions from earlier units. For this, we will refer to subsection YZ of unit X as section XYZ, or to section Y of unit X as section XY. We will also recall some results from our earlier course, BMTC-131 on calculus. We shall refer to a unit in this course as unit X of calculus. What we had said in our calculus course remains true for this course too. To master the various techniques presented here, you will need to put in a lot of practice. In case you want to seek some additional information about the concept discussed here, or to solve some exercises, you can consult the following book, Calculus 3 by Gerald Marsden and Alan Winston Springer. This will be available in your study center library. We hope you find the techniques developed in this course useful in your further studies.